Chapter 1 till 1.4 completed. Today I'll start example 12, page number 19. Check whether 7 root 5, 7 by root 5, root 2 plus 21, pi minus 2, these are all irrational numbers or not. Value of root 2, root 5, pi. Root 2 is 1.4142 dot dot, root 5 2.236 dot dot, and pi is 3.1415 dot dot. You have to memorize these values. 7 root 5. Root 5 value is 2.236 dot dot. You can multiply this. You will be getting 15.652 dot dot dot. Since it is non-terminating, non-repeating decimal, so it has to be a rational number. Now second one, 7 by root 5. Downside root has to be removed. For that, multiply both by root 5. 7 root 5 divided by root 5 makes 5. Because when double root 5 you are going to multiply 5 into 5, you will be getting under root. 1 5 will be out. Yeah, root 5 whole square, when you are getting root and square both can be removed, you will be getting also 5. So 7 root 5 by 5. Root 5 value you can put 2.236 dot dot, multiply 15.652 dot dot dot, divide by 5, you will be getting 3.130 dot dot. This also non-terminating, non-repeating decimal. So 7 by root 5 is irrational number. Now root 2 plus 21. Root 2 value is this one. Already I told you to memorize it. Plus 21. Addition is done here. Answer is 22.4142 dot dot. This also non-terminating, non-repeating decimal. So it must be irrational number. Next one, pi minus 2. Value of pi 3.1415 dot 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 minus 2. You can subtract. You will be getting 1.1415 dot dot. This also non-terminating, non-repeating. So pi minus 2 also irrational number. Now I will teach you how to add these two. First one, 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. Cover with a bracket first, then open the bracket. Just like algebra, 5x plus 2x is to get 7x, 3x minus 2x is to get x. Like terms can be added, can be subtracted. Same thing here. If under root number is same, then can be added. It can be subtracted also. That's why 2 root 2 and root 2 we are taking together, and 5 root 3 and 3 root 3 also we are taking together. 2 root 2 plus 1 root 2. Root 2 same. That's why their coefficient can be added. 2 plus 1, 3 root 2. Plus 5 root 3 minus 3 root 3. 5 and 3 can be subtracted. You will be getting 2 root 3. So whenever you are doing addition subtraction, make sure that under root number should be same. Then only its coefficient can be added, can be subtracted. Now page number 20, example 14. Multiply 6 root 5 by 2 root 5. This into this. Rational should be multiplied with rational. Irrational will be with irrational. 6 to the 12 into under root 5 into 5 we are getting. Inside double, outside single. 12 5 is 60. For division also rule is same. Divide 8 root 15 by 2 root 3. 8 root 15 by 2 root 3. Rational can be divided with rational. Irrational will be with irrational. 2 4 is 8. Under root 15 by 3, which is coming out 5. So 4 root 5. Now I'll teach you about rationalizing the denominator. In 1.5, its importance is very much. You need to learn. You should learn very well. Rationalizing the denominator means to make a rational denominator. For that, what to be done? Just multiplication. If your denominator is single root, like root a, then multiply by root a, so that root can be vanished from the denominator. Rational denominator means root has to be removed from the denominator. So root a into root a becomes root a square. Root and square together comes means it will be a. Again, when you will get like this format, a plus root b multiplied by a minus root b, root will be removed. If your denominator is a minus root b, then multiply by a plus root b in this form, your root will be vanished. If you have root a plus root b, then root a minus root b you can multiply. If you have root a minus root b, then root a plus root b you can multiply. Root will be vanished from the denominator, and it will be rationalized also. Rationalizing the denominator means to make a rational denominator. Now this and this, they are called conjugate to each other. This is conjugate to this, this is conjugate to that, this is conjugate to this, this is conjugate to that. You need to learn very well. Now page number 23, example 18. Rationalize the denominator of 1 by root 2. Downside single root. So multiply both by root 2. Root 2 1 is root 2, double root 2 makes 2. Becomes rational denominator. Example 19. Rationalizing the denominator of 1 by 2 plus root 3. Downside you have 2 plus root 3. It is a rational number. Since two numbers are together, multiply by its opposite sign. You will be getting 2 minus root 3, 2 minus root 3. So upside 2 minus root 3, downside a plus b, a minus b. It becomes a plus b, a minus b formula, that is a square minus b square. So it looks like a plus b, a minus b. So you can make it 2 square minus root 3 square. 2 square is 4, root 3 square is 3. So 4 minus 3 becomes 1. So your denominator is 1. It became rational denominator. Downside 1 normally we are not writing. So 2 minus root 3 is the answer to this. Again, many more questions are like that, which I will teach you in the next class. For today, this much.